This seems to be an interesting one. We're not given very much. I don't see much vocab in there. So the idea behind most of these proofs are they're tied to some vocab words like supplementary or midpoint. They just give us the idea that 1 and 3 are the same measure. And I guess they tell us that we have a line there. So what vocab word, looking at our pictures, are we referring to? Actually, I think in our notes we actually put that picture with that one. Can you find that? Maybe pause the video and look for that. If you find it, it should say supplement theorem. The vocab word we're tying to this is a linear pair. 1 and 2 form a linear pair. That's why they told us there was line AC. They probably didn't have to tell us. In fact, this is one of those things where vertical angles, they're not always going to tell us we have vertical angles. We know what they are. We're supposed to look for them, and we're supposed to recognize that. Here, same thing. We're supposed to recognize angle 1 and angle 2 form a line. They don't even have to tell us that. So what's the conclusion that we make when we have a linear pair? Again, maybe pause the video and check that conclusion. Make sure you know that before I just tell you. We conclude that the angles are supplementary. So in this case, angles 1 and 2 are a linear pair, so we'll conclude angles 1 and 2 are supplementary. That's it. That's the conclusion. Now, a lot of students want to say and right away that their measures equal 180, which we know is going to be true, but with a proof, you've got to have a reason to justify it. And our supplement theorem doesn't say their measures add up to 180. It just states that they're supplementary, but that's okay. One thing will lead to the next, and then we'll be able to say that the measure of angle 1 plus the measure of angle 2 equals 180. Definition of supplementary angles. If you find that one, you can see that's just like the conclusion that the definition of supplementary angles makes. Well, that's really all we have given to us. Can we fit that together? We're supposed to prove that measure of angle 2 plus measure of angle 3 is 180, which I know that 1 and 2 add up to 180. How do I get 3 in there? Do you see it? The replacement rule. What are we going to replace? What's equal to each other that can replace one another? Well, the 1 and 3, so we can replace either one of those. In that second equation, we have another 1. It can get replaced with measure of angle 3, which really shows us exactly what we wanted to prove, other than the fact that the 2 and 3 are switched around. But after doing all of those algebraic proofs, maybe you know what property that is. It says, you know what, you can switch the order. If you want to pull out that old sheet that had all your algebraic proof properties, you might find it. Actually, this algebraic proof property I left on your sheet with the geometric properties, just so that you'd be able to use it in these proofs. Commutative property of addition. Something is commutative if it can be switched back and forth. It's like it's commuting, going one and then the other. It's switching, work to home, work to home. So it's commuting. It's commutative. Addition is commutative. And so we can switch the order here.